And now for our last property that we look for when we are given parallel lines, or how we can prove parallel lines, is co-interior angles. So co-interior angles is a U shape, but it works a little bit different. So co-interior angles are not equal to one another. They're actually supplementary, meaning they add up to 180. Yes, so now we've gotten to the U, so fun is completed. Very, very exciting. So this is now if we're looking for a U shape where the two lines of the U is on the parallel lines and the like underneath part of it is on the transversal. So we do not have that these are equal to one another. In fact, we have that if this is x, then this one has to be 180 minus x, because when we plus them, we get 180. So we have already previously done something else with adding up to 180, and that's angles on a straight line. Okay, so let's quickly see kind of like where this comes from. So if we look there at the parallel lines, you can also draw an F, right? Or Z. Okay, so if this is x, then this one will also be x. And because this is the same vertex here, then this one and this one must give you 180 when you add them together. Yeah, so that's another way you can go about it. But I think oftentimes, like, especially if algebra gets involved, and it's not a simple just value and value, but we get an x or some letter involved, then oftentimes co-interior is going to be an easier way for you than going corresponding or alternate routes and then using angles on a straight line. It's allowed, but it's unnecessary, basically. So here, again, if we look at this, it can be in all different shapes. Well, not shapes, it's always a U, but all different like directions and orientations. Maybe some advice for any part of geometry, really. If you don't really see anything, like you are trying to figure out what property am I supposed to use here? Because now, as of today, we've done 6 of them. And we are not done because we are still going to do 2D shapes. And there are some there also. So there's a lot of things you can be looking out for. Then, okay, obviously if you see parallel lines, it's these 3. The co-interior, the corresponding, and the alternate. But if it doesn't look quite right, turn your book around till it makes sense, till it looks familiar. And obviously remember your colors when you go write geometry. Just like the other ones. If we are given parallel, then we can say co-interior angles are, no, they're not equal. This is the odd one out. They are adding up to 180. They are supplementary. That's the fancy word we learned like right in the beginning. So now supplementary, that add up to 180. Here's your abbreviation for co-interior, is co-int, with the lanky there, the koppelteken. And then you add the lines of parallel because just like the other ones, something whack like this one and this one, they are still co-interior, they're together on the inside. Okay, if you also think of it just like breaking up the word co, like a colleague, a co-worker, together. Interior on the inside, so co-interior together on the inside. So with the co-interior angles, they are also co-interior, but they are not supplementary necessarily. You can kind of see they're both obtuse angles, so they can't be supplementary. So it's because the lines are parallel that make them supplementary. So you need to have both parts of your reason there, otherwise, just like the other 3, your reason is not complete. And then if they ask you to show or prove co-interior, then if you can find that the 2 angles on the inside of the parallel lines, on the same side of the transversal, okay, together on the inside, on the same side of the transversal, if they are adding up to 180, then the lines are parallel because the co-interior angles are supplementary. So that's your reason. Again, we're going to look at an example where we are going to be using the properties, and then where we are going to do the converse or use the converse, where we are going to prove. Okay, prove parallel or show parallel. So just like all the other ones, we're going to take it one transversal at a time. So here's our first one, and we see the information is both going that way. So we know that x and 130 together, when you plus them, gives you 180. So then you just need to do your normal algebra from there, and you minus your 130, and you minus your 130 on both sides, so that you can get x is equal to 50. So we have x plus 130 equal to 180. We can't just write that. It wasn't given to us there. There was a picture, and now it's algebra. It's not magic, it's maths. You need a reason, because it was actually from a picture to algebra. It was from geometry to algebra. So we say co-interior angles, and we add our parallel lines, which is still A, B, and C, D. Next one, the U is going this way. So y plus 60 is going to give us 180. So you are actually allowed to start just by saying y will be 180 minus 60. That is perfectly fine. You are allowed to do that. Or if you straight can see the answer, okay, I have 60. I need to get 180. So to get to 80, I need 20. In other words, I need 120. You can just write down the answer also. And then your reason obviously needs to be there with the parallel lines. This last one, so now I'm going to show you how you can just go write the answer straight also. You have 110, you need to get to 180 because the two must together be 180 when you add them. You have 110 to get to 80, from 10 you add 70, so z is 70 because same reason. So it doesn't matter how you go about this, if you straight go write the answer, if you start by saying 180 minus, or if you start by making equation in this way, all of those are acceptable. The question will be 2 marks either way. It will be one for the answer and one for the reason. Again, here we are going, just like we said earlier, we are again going to show parallel, given that all we know is that this one, and this one, they're all straight lines. Okay, that's all we know. And we have to show parallel. So if we look back, showing parallel, you identify if you're going to use F, U, or N. Now in this case, you have bits of information to use Z also, but we've already done that in the alternate angles video. So let's do a U one, just so we know how to prove that also. So here we identify, we need to show that when we plus this one and we plus this one, our answer should be 180. Then we're going to use our third angle to try and solve x, either angles on a straight line or vertically opposite angles. So here's our third angle, and it's angles on a straight line with this one. So when you add them, you get 180. Angles on a straight line is your reason. And you go see, okay, there's 3x plus 5x. So altogether we have 8x. And then minus 10 plus 70. So 70 minus 10 is 60. Go identify over here. We have a times 8 and then a plus 60. So we first have to minus 60 and then divide by 8. So we're going to get 15 as an answer. Then our next step is going to be show that they are equal. Is it? Remember, this is now the one where we are deviating. F and N work the same. U works different. We're not going to show that they are equal by first substituting. Sorry, we have to substitute first. We are going to instead show that they add up to 180. So we go substitute. It's E1 and F1 again. In the first case, we're going to get 35. In the second, 145. Now we're going to, instead of proving them equal, show that when we plus them, we get 180. And then we can say they're parallel because this will be co-interior angles are supplementary, or just co-interior angles supplementary. So we see E1 plus F1 is going to be 35 plus 145. Oops, forgot the one. And that gives us 180. So therefore, sorry for how low this is now going. Therefore, AB and CD are parallel to one another because the co-interior angles are supplementary. And we're done. So in our next video, we will now be going over to our geometry of 2D shapes so that we can look at our properties of our triangles as well as our properties of our quadrs.